Alright, so we're going to be starting chapter 2. Again, we're still doing quadratics, but we're not going to be doing vertex form in chapter 2. Instead, we're going to be going back and doing standard form. Standard form looks like this, where you have ax squared plus bx plus c equals 0. So that's standard form. We're going to be doing that a lot in chapter 2. And so to start, we're going to review, well, we're going to review a lot of the stuff we initially reviewed before we did chapter 1, right at the beginning of the course. And we're going to go over some things such as a polynomial, simplifying, expanding, and factoring. Okay, so today's going to be a review of a lot of those skills which we're going to need in this chapter. Okay, including dealing with exponents as well. All right, so let's start with simplifying. So here we have an example, and we need to simplify. So this is a negative here, and that negative needs to be multiplied into the entire bracket, not just the first term. Okay, it's the distributive property. So you can think of that negative as a -1, but we don't usually write a 1 there. So the first one, there's nothing in front, it's just a positive 1. So we can just drop those brackets. So we have 3x plus 4y. And then the negative is going to change every sign in our second bracket. So we have minus 5x. And then a negative gives us positive 6y. Okay, from here we're going to collect like terms. So remember what a term is. I have it up here. A term is the product of a numerical coefficient and a variable portion made of one or more variables. Yeah, okay. So coefficient, a numerical coefficient, for example, 4. Right? And then a variable portion, for example, x. Okay, it could also have an exponent on it. And it could also be one or more variables like this. Okay, so this is your coefficient. These are your variables, that's your exponent, and the whole thing is your term. I don't know if it helps if I'll write that out. So this is your coefficient. These are your variables. This is your exponent. And the y would also have an exponent. It's just going to be a 1. But if something's to the exponent of 1, that's just itself. So we don't bother writing 1. But it is there because it's certainly not 0. Okay. And the whole thing is our term. Okay. Now when you're identifying like terms, you're identifying terms that have the same variable or variables with the same exponents. So in this case, x to the 1 and x to the 1, these are like terms. Okay, that negative is part of that coefficient. This coefficient is -5, so it's part of the whole term. So 3x minus 5x gives us -2x. And of course here we have two other like terms because they both have the same variable with the same exponents. So 4y and 6y is plus 10y. Okay, so a couple other terms we have here. A monomial is just a polynomial with one term, and a polynomial is just an expression that has terms that are added or subtracted to each other. So this one would actually be a binomial. I don't actually have a binomial written up here. Oh, here I do. A binomial. Polynomial with 2 terms. Try 3 terms. Okay. So next we're going to review the exponent rules. So first rule. when you're multiplying exponents that have the same variables, when you're multiplying variables with the same base, you add the exponents. So this is going to be x to the 3 plus 2, which is x to the 5. Okay, when you have similar bases means the same variable, not necessarily the same exponent or the same coefficient, just the same variable or base. So in this case, you have different coefficients, but you can multiply those separately. So just 2 times 5 is 10. And then you have the variable x, which are being multiplied. Since you're multiplying the same base, you add the exponents. This is a 2, and it doesn't say it has an exponent, but that just means it's 1. So 2 plus 1 is x cubed. Now this one, I don't really like using this symbol. I much prefer to write division as a fraction. Okay, and when you're dividing similar bases or the same variable, the exponents get subtracted. So it's 4 minus 2. So this equals x to the power of 4 minus 2, which is just x squared. And lastly, again, I'm going to rewrite this as a fraction because I prefer that. Divided by 2x cubed. So the coefficient we can look at separately. We have 4 divided by 2, which is just 2. And then we're dividing similar bases, which is x. And since we're dividing, we subtract the exponents. 5 minus 3 is 2. Let me just pause there. Okay, there's one more thing I wanted to go over, just in case we need it, is our third exponent rule. So I'm just going to create a part E here. So if we had, say, x to the power of 2 to the power of 3. So anytime you have a power to the power of something, right, an exponent to another exponent, in that case you multiply the exponents, because this is the same thing as saying x squared times itself 3 times. So x squared times x squared times x squared. Okay? And that's just 2 plus 2 plus 2, or 3 pairs of 2, 3 pairs of 2, which is multiplication. So that'll equal x to the 2 times 3, which equals x to the 6. So that's our third exponent rule. Next thing that I would ask you to do sometimes is to sort of look at an actual situation and come up with an expression or an equation. So in this case, we have a square where one side is x, because it's a square, all sides have the same length, x. And it says state an expression for the area. Well, the area, if you remember, is length times width. And since the length and width is both x, that's just x times x. They're each to the power of 1, so you add your exponents and you get x squared. Okay, so the area equals x squared. Alright, so we're going to review the distributive property. We've used this quite a lot. And if you have brackets and you're multiplying the brackets by either a variable or a constant, and inside the bracket maybe you have a polynomial. Okay. The term outside the bracket simply needs to be multiplied into every term inside the bracket. So in this example, the 2 gets multiplied into both 2a to give you 4a, and the b to give you 2b. The negative 3, and this is important, that negative is with the 3. You're not just putting multiplying 3 into every term. You need to multiply every term by negative 3. Okay, so negative 3 times positive 3 gives you negative 9. And then you still have that a term. Again, a negative and a negative gives you a positive. 3 times 2 is 6, and we have that b term there. At that point, you need to simplify. So we did the expand. That's a distributive property. Now we need to simplify. So here we have a like term, and here we have a like term. Just remember that negative is part of that term. And then we have these two like terms, here, and here. So 4 minus 9 gives us minus 5a, and 2 plus 6 gives us 8b. So we can do the same thing here. Just have to remember that that entire term gets multiplied into every term inside of the brackets. So first you can look at the sign. Right? Negative and a positive gives us a negative. Then the coefficient, 3 times 2 gives us a 6. Then the variable x squared times x, using our exponent law, gives us x cubed. Next one, 2 negatives gives us a positive. 3 times 5 gives us 15. And then we're still left with that x squared. Okay, and there's no like terms here, so we can't simplify this any further. All right, so last for today, we're going to practice some expanding and simplifying. And as we do that, we're going to notice a couple patterns that we went over before, such as a perfect square and a difference of squares. Because we can use those to factor, which is what we will be doing in the next couple of lessons. All right, so for the first one, if we're going to expand, this negative needs to first multiply into every term inside those brackets. So the first trinomial, there's just a positive 1 outside, so we can just drop the brackets. We have x squared minus 4x plus 1. That negative here is going to change the sign of every term in those brackets. So we have minus 2x squared plus 3x minus 4. And this is where you can collect like terms. So here's our x squared term, including the negative. We have 1, because there's a 1 there. We just don't write it. 1 minus 2 gives us minus 1. But again, I'm just going to write minus. I don't need to write the 1. So minus x squared. Then we have these like terms with just our x variable, each to the exponent of 1. We have minus 4 plus 3 gives us just minus 1. But again, I don't need to write the 1. And lastly, we have our constants at the end. 1 minus 4 gives us minus 3. Now, if we are using the distributive property with two binomials, this is where we're going to FOIL. Okay? So we're going to have the x, the first term of our first bracket, multiplied to both terms of the second bracket, and then the first term in our first bracket, multiplying into both terms of the second bracket. So we'll do it one at a time. We get x times x, which is x squared, x times negative 4, remember that's part of this term, that gives us minus 4x, and then 3 times x gives us plus 3x, and then 3 times negative 4, positive and negative, gives us a negative. 3 times 4 is 12. And we only have two like terms here, and those are the two middle terms. So we're left with x squared. Negative 4 plus 3 is just negative x, and then minus 12. Okay, so the next one is our perfect square. So we just have this bracket squared. So if we're going to expand that, easiest thing to do is just to write it out twice. I'm not going to give you any exponent bigger than that. We're not going to have 2x plus 1 to the power of 5 or anything. So the easiest thing to do is to just write it out twice, and then do the exact same thing we did over here where we multiplied two binomials. So first, 2x times 2x gives us 4x squared. 2x times 1 just gives us 2x. And again, 2x times 1 gives us 2x. And then 1 times 1 just gives us 1. The middle terms are our like terms. And so we have 4x squared. 2 plus 2 is plus 4x. And then plus 1. And so when we factor, we notice that this does sort of give us a pattern. Okay. Same with difference of squares. There's a pattern there too. So we have 2x plus 1 and 2x minus 1. When we expand that, you might be able to see what's going to happen to those two middle terms that we usually have like. So 2x times 2x is 4x squared. 1 times 2x is plus 2x. But now we have 2x times negative 1, which is minus 2x. And 1 times negative 1, minus 1. So here are our like terms. And we have plus 2x and minus 2x. And so 2x minus 2x, they cancel. Alright, so I have more disk space now. So let me just do a recap. So for a perfect squared, when we multiplied these two binomials together, just like we did up here, the two center like terms added, and so essentially doubled. But for a difference of squares, again, we just multiplied two binomials together, like we did up in part B. But for a difference of squares, the two center like terms cancel each other because they add to 0. Right? So that term with just our variable x is gone. It's fairly easy to recognize a difference of squared, but a perfect squared can sometimes be harder, but we'll practice factoring them in tomorrow's lesson. Now this one gets a little bit more complicated. We have a perfect squared here, and it's being multiplied by 3x. So what we can do is just write 3x, leave it out for now, and we'll make a nice big bracket and we'll deal with our x minus 2. Now we can write it out twice, and we can FOIL it. But as you get used to perfect squares, you're probably going to get faster. Right? You'll realize, oh, your first term is just x squared. Your last term is plus 4. And then the two terms in the middle are identical. Minus 2x and minus 2x, which is going to give you minus 4x. But you don't have to do that in one step. If you want to write it out first and then add the two like terms, that's fine. But we're not done expanding yet, because we still have this 3x out here that we have to distribute into this large bracket that we created, into every single term. So the first one gives us 3. X times x squared is x cubed. Right? We're just adding the exponents. The next one, again, that negative is part of our term. So 3 times negative 4 is minus 12. X times x is x squared. And our last term, 3 times 4, is just positive 12x. And there's no like terms there. So that's it for that question.